Hello guys, Oscar Hotel 8, Sierra Tango, November here from Survival Tech Nord. Many of us have that goal of operating off-grid, portable, or in some exotic place around the world, but we really don't know where to start. Well, in today's video, I'm trying to present to you everything I know about operating portable and off-grid. It's going to be an insanely in-depth video, but I hope you'll find it the most comprehensive video of its type on the internet. So join me and we'll start the ultimate guide to off-grid ham radio.
You are listening to the Emergency Broadcast Systems. This station broadcasts emergency news and official information on the air for assigned area.
Operating in a park or during your lunch break is a little bit different than operating off-grid in some remote location. And even so, with some careful planning, we can actually come up with a strategy addressing short-term recreational deployments as well as extended field communications off-grid in some faraway place. The only problem most of us will face when coming up with that strategy is the fact that we actually need some field experience before we can do so. It's a little bit like the chicken and the egg problem, but I promise you, we are able to get there. So let's go ahead and take a look at many of the considerations we have with an off-grid ham radio deployment. And first and foremost, we want to understand the mission and we want to understand the goals. Understanding the mission and the goals is not only important for deployment, it's also important when we're just starting off with portable field communications, since answering these questions helps us understand communications gear and equipment requirements. Questions like, how long are we going to be off-grid? Are we trying to make random QSOs or reaching a specific station? What's our plan for transmitting and receiving? How do we get there, and where do we operate from once we are there? And for long-duration deployments, how do we avoid operator fatigue? For example, knowing how long we're going to be out there, who we're trying to talk to, and how often we're trying to talk to them helps us to understand our battery and charging requirements for the station. Knowing who we're trying to talk to and how far that station is from our own helps us understand the required capabilities of our radio equipment, the bands and time of day, as well as the antenna requirements to reach out to those stations we're trying to talk to. Bottom line, every gear and operating choice we make has an effect on our station performance and longevity. For the sake of this example, let's say we're operating 100 watts, portable, SSB, in something like field day or contesting. Let's say using a 5 amp hour battery, we can operate that station for an hour. In contrast with that same 5 amp hour battery operating at, for example, 20 watts, with a more efficient mode like CW or narrow bandwidth data mode like JS8 Call, we can actually use that 5 amp hours to operate for several hours without any noticeable loss of performance. This is important because the off-grid ham radio operator can't afford to waste any energy. So we utilize every method we can to reduce our energy footprint and stay on air. For example, using the most efficient communications mode we can to achieve our communications goals. Or using high energy density batteries like lithium ion or lithium iron phosphate to increase operating time but reduce station weight. We can also use lightweight, easy to deploy but efficient antennas to help with the efficiency of our stations. Where constant communications are required, we can use radios with a very low receive current draw. And probably most important for the off-grid field radio operator, simultaneously charging our stations while we're using our radios. I've said it more than once on the channel, a station with a dead battery or battery packs which can't be recharged in the field become a boat anchor when they're dead. So we want to avoid taking radio or battery packs to the field which we can't recharge while we're out there. Choosing the right radio for off-grid operations can be one of the most difficult and painstaking choices we make. But we can't break down the features and functionalities which are most important to the off-grid field radio operator. Now, before we go into that, we need to discuss off-grid for a second. Off-grid doesn't necessarily mean very remote or in the middle of nowhere. It simply means we are without grid power. Where we are, or why there's no grid power, is actually irrelevant. Our goal is simply to make the best of the situation we're in and keep our communications up and running for the duration of this off-grid scenario. So, a few days ago I posted to Patreon, YouTube, Instagram, Twitter, and my Facebook page. I asked all of you to let me know what you thought the most important features were for a radio being used off-grid. And actually, from these answers, we can see the off-grid community is a very practical bunch. So here's what we came up with. By far, more than any other suggestion, low current draw was at the top of the list for the required features of our off-grid radio. And actually, I really couldn't agree more. Generally speaking, we have a finite amount of battery storage. If our radios are sipping that storage rather than gulping it down, that storage is going to go a heck of a lot further. So at the top of our list, we have low receive current and efficiency. People responding to our question also suggested a radio be lightweight and rugged. Excluding the green radios we see on Guild Radio Preppers channel or my Vertex VX1210, most of the ham radio manufacturers are producing radios which are not rugged. The exception to this might be the ICOM 7200. Until amateur radio manufacturers start to supply rugged and lightweight radios to this niche market, we'll have to come up with clever ways of protecting our stations when we're operating off-grid or in the field. Another popular point coming up during this discussion was the ability to charge and power our radios from some external DC source. This topic helps us understand radios designed for operations during your lunch break versus radios which were designed to operate continuously off-grid. For the portable variants of these radios, we're looking for internal batteries and a wide voltage input. Still, it's not unheard of for us to use external battery packs with radios which don't include their own internal power supply. Perhaps what's most important for this part of the discussion is our understanding of the options for powering our radios off-grid and in the field. Another interesting point coming up during this discussion was a radio's ability to be interfaced with. A pretty big number of operators believe a radio used off-grid should have a one-wire interface for both audio interfacing and CAT control. And again, I couldn't agree more. Having a one-wire interface for CAT control and audio interfacing alleviates the wire mess and the amount of things we have to connect to externally to carry out data mode communications or logging when we're in the field. It's just important to keep things like this in mind when you're choosing your next off-grid radio. And very closely related to the single-wire interface is having everything built in. Operators are saying we should have a built-in tuner, we should have a built-in battery, audio interface, and of course that one-wire interface for audio and CAT control. Now when we're talking about full-size radios, it's possible to find these features, for example the ICOM IC7300 or the Yaesu FT991 Alpha. When we're talking about lightweight portable radios, it becomes a bit more complicated. This is my FT817ND Go kit. It includes the 817, it includes a 10-watt amplifier, a Raspberry Pi, the PowerFilm Lightsaber Max, and an LDGZ 817 tuner. The tablet you see on the left there can connect wirelessly to the 817 with the integrated, in quotes, Raspberry Pi. Now as you see, I have these devices velcroed to the top of the 817ND. This certainly helps, but it doesn't solve the wire mess problem. When we look at the little Yaesu from behind, we can see that when I'm using an antenna tuner, I have cables going from the tuner to the FT817. I have cables or wires going from the amplifier to the FT817. And of course I have cables or wires going from the Raspberry Pi to the FT817. This is exactly the same as the Yaesu FT818. The primary point I'm trying to make here is each one of these wires and connections is a potential point of failure. If we could have a radio with all of this functionality integrated into the enclosure, we would most likely have the ultimate portable off-grid radio. Now this is my Xiegu G90 Go Kit. It's very similar in design to my Yaesu FT817ND Go Kit, but it's missing a couple of components. So it includes the Xiegu G90, it includes a Raspberry Pi, it includes the PowerFilm Lightsaber Max to power it up, and an audio interface because it doesn't have an internal audio interface built in. Now because it already has an internal antenna tuner and 20 watts output, I get rid of the amplifier and I get rid of the external antenna tuner. Looking at the back of the G90, we see there are fewer cables. Of course we could add one more for cat control if we were using it, and of course we have a power cable out. So what you may have noticed now is I'm using a Raspberry Pi on all of my radios. The Yaesu FT891, the Yaesu FT817 and 818, and the Xiegu G90. Now as you see with my Yaesu FT891 portable setup, this has the added benefit of no wires between our tablet or laptop and the radio and Raspberry Pi. So perhaps where I'm going with this is starting to make sense now. If we're looking at portable off-grid communications, there really is no amateur radio manufacturer who supplies all of these capabilities which we would expect in an off-grid radio. Even without the release of a practical off-grid radio, we can still get a pretty clean installation by moving the processing power from our laptops or tablets to a Raspberry Pi integrated with our radios. Now, whether you're a ham radio beginner or a seasoned veteran, the best thing we can do is choose rigs and components which make our off-grid or portable operations easier, not more complex. Now I think it's a great time to start talking about power for off-grid communications. This is my 256 watt-hour lithium iron phosphate Power to Go Go Kit. It includes a 256 watt-hour DIY lithium iron phosphate pack. It also includes a 64 watt-hour DIY lithium iron phosphate pack or backup pack. It includes the Buddy Pole Power Mini solar charge controller, two PowerFilm Solar FM16 1200s, those are 20 watt panels, and various cables and adapters. Now this core kit is designed to power any of the radios I have in my arsenal for an unspecified amount of time. Now we can use a kit like this to power a QRO 100 watt radio with a reasonable duty cycle anywhere from 18 to 72 hours. The range of operating time depends on the amount of solar power or other augmented DC power we have coming in to power or replenish our batteries. In the field test you're watching right now, I'm using the Yaesu FT891. I'm using the 256 watt-hour lithium iron phosphate pack, the Buddy Pole Power Mini, and one of the PowerFilm Solar FM16 1200s, the 20 watt panel. Now you're probably wondering what the heck I'm thinking using such a small panel, but there's a point to be made here. Almost any amount of solar power we have coming into the system will extend the runtime of the system overall. So our point with using such small panels for off-grid communications is being lightweight and portable. With these panels, we can actually more than make up for the receive current of the radio and the Raspberry Pi. Then slowly recharge the battery pack, or at the very least, extend the discharge time of the battery pack using these small panels. Here's something you need to take away from this video. If we're using a radio which has a lower receive current and we also use a more efficient mode with lower output power, augmenting our lithium iron phosphate battery packs with solar power means we can stay out in the field operating almost indefinitely. By this point in the video, I'm hoping you're beginning to understand how through good planning, we can configure our systems for both short-term deployments as well as extended field communications off-grid. I don't know about all of you, but I'm not very convinced by someone just talking in a YouTube video and not actually proving what they're saying is valid through field testing. Around the end of May 2020, I rented an off-grid cabin from a place called Rakua Geopark, located about 50 kilometers from my home QTH here in Finland. The goal was actually pretty simple. I would use that 256 watt-hour portable power kit to power my station, a 20-watt station this time, not the FT891, and all of my YouTube gear, along with a QRP radio that I would use for short excursions for 3 days. Now, rather than using the small panels, I wanted to use the PowerFilm FM167200. This is the large folding solar panel you've seen on many of my previous expeditions. The catch-22 is I would only be able to use it in the morning sun. So naturally, I started off the expedition with a full battery pack. However, each morning I had 4 or 5 hours of direct sunlight just next to the river there, where I could replenish the battery. Once the battery was full, I would disconnect the solar panel and run the Raspberry Pi and the Zygo G90 off of the battery pack for the entire day. I started each morning with about 13.0 to 13.3 volts on the battery pack. If I timed it just right in the morning, I could easily get that pack full with full sunlight within a couple of hours. Now, it was very important that this system, the battery pack and the solar charge controller, were either easy to set up or mostly set up already. In part, this is why I used the Buddy Pole Power Mini instead of the Geneson controller I would normally use. So setting up was pretty simple. Plug in the battery, set up the solar panel, then plug it into the Buddy Pole Power Mini. The battery started charging within a few seconds. After that, it was just a matter of plugging in my tablet if it wasn't charged already, plugging in the Raspberry Pi, and plugging in the radio. Overnight, I would bring everything inside the cabin and set it up on one of the chairs. And here's another one of those takeaways from this video. This radio and Raspberry Pi take about 650 milliamps just sitting there receiving and running JS8 coal. I also use the system to top up my tablet each day and to charge the QRP radio that I also brought along with me. So you see, once you have your equipment, once you've made your equipment choices, once you've decided how you're going to configure your station, when you actually get out in the field, most of the lessons we're going to learn are related to conserving energy from our radios and our computers. Now, regarding the conservation of energy, most of the time I was running about 10 watts, but sometimes up to 18 watts. I ran JS8 coal and JS8 coal utilities constantly, day and night, for the entire time I was there. Now, I made some very nice QSOs with JS8 coal, but I have to admit, it was very challenging when I was running the lower end of my power. It's important to point out, even with the difficulties I had in staying in touch with low power, if I were using a mode like SSB or some wide bandwidth data mode, these QSOs and keeping in touch would have been impossible. Now, the mode we use for off-grid communications isn't only important in terms of efficiency, it's also important to choose a mode which actually works for the radio operator. In this case, a utility mode which is actually going to put me on an APRS map, even if I'm out of the range of the closest digipeater. A utility mode which will allow people who aren't necessarily amateur radio operators to follow my station's progress and plot its location anywhere in the world. And a utility mode which will actually sit there doing the work for you, collecting messages sent to you, although you might be doing something else like eating or simply enjoying the nature around you. Now, there certainly are different reasons why an operator would go off-grid with amateur radio. De-expeditions is probably the most popular amongst them. However, there is emergency communications and simply keeping in touch with friends, family, and other operators. Using amateur radio without the worry of any intermediate infrastructure requirements. The role of this channel is always going to be about learning to operate off-grid. Researching, building, and integrating tools which allow us greater capabilities when we're trying to communicate off-grid. And finally, keeping our communications up and allowing us to capture the journey along the way. If you're supporting this channel through Patreon, PayPal, or simply sharing my content, you're absolutely magnificent and I couldn't do it without you. For the rest of you, if you like what I'm doing, if you like the content I'm creating, leave me a comment and a thumbs up to let me know. And if it's not too much to ask, please share this video with someone or someplace where other operators might enjoy it. Rock and roll, guys. Thanks for watching. Ciao.